Hey, yo. What's up, y'all? Gordias here, coming at you live for a video on systems of equations by substitution. Let's get it. All right. So, when we're talking about a system of equations, it's when we have two equations with the same variables, but there's normally two different variables in those two equations, and we want to solve for both. So, this particular system has a same x and same y that is a solution to both of these equations. So we're trying to figure out what x and what y is the solution of both of these equations. Now, what we've already learned, this should say 8.2 by the way, 8.2. What we've already learned is how to solve this by graphing. So let me just do that real quick. I'll do a quick sketch just to kind of show us how we did that in case we forgot. So I would graph both of these equations on the same coordinate plane, because this is a line, this is a line, so these are two lines. If we figure out where those two lines cross, that would give us an x and a y that's on both of those lines. 3x plus 5, 1, 2, 3, 4, 5. There we go, down 3, 1, 2, 3 over 1, 1, 2, 3 over 1, and it would look something like that. I know it's not perfect, it's okay, I'm not actually worried about the solution right now. And then I would also graph y equals 4x. That's at 0, 1, 2, 3, 4 over 1, 1, 2, 3, 4. And it's going to look like this. Now, these are eventually going to cross. And it looks like if I extend them, they'll cross somewhere up here. Okay, so my solution to that system would be right there. Now, that's how we solve systems, by graphing. But the reality of the situation is we don't always have a graph available to us. Okay, we don't always have a coordinate plane, and sometimes graphing is just not very easy because it's going to take a while to find the solution. Also, if the solution is not at a perfect point, graphing is really difficult to do. So we're going to learn how to solve systems instead of by graphing to figure out where they cross, we're just going to solve them by solving equations algebraically. Now, looking at this, let me show you. Let's talk about what we can do here. If I were to give you the equation like x plus y equals m, but then I said, hey, x equals 2, y equals 5. Okay, what we would do to solve this is we would say, hey, like if I know x is 2, I would just plug in 2 for x, I would plug in 5 for y, so I have 2 plus 5, which is 7, so m equals 7. What you would do is you would do a substitution, because you know what x is and you know what y is, because this says x equals and this says y equals. Well, that's what we're going to do when we solve systems by substitution. We're going to do the same thing. We're going to make a substitution like what we did here. We substitute in what we know for x. We substituted in what we know for y. Now, I know some of you are like, okay, Gordias, that makes no sense because I don't know what x is and I don't know what y is. Well, yes and no. I mean, we don't know what x is, right? I had 3 times x plus 5. I don't have an x equals any number over here. But I do have a y equals. If we notice, this is just y is already by itself. I've solved for y on both of these equations. I just have y equals this whole piece. Yeah, it's not a single number, but I do know what y is. Y is just 3x plus 5. I also know that y can also be considered just as 4x. So these are both, y is known as just 4x and y is known as 3x plus 5. So what we can do is, since I know what y is, I can substitute in either one of these for y in the other equation. So I know y equals 4x, so I can substitute in 4x for y in my first equation. Let's do that real quick. If I replace these two, if I replace y with 4x, because I know what y is. Y is equal to 4x. So I'm going to put 4x for y here. So I'm rewriting this equation, but instead of y, I'm writing 4x for my second equation. So because I have because y is equal to 3x plus 5 and y is equal to 4x, really I'm setting these equal to each other. 4x is equal to 3x plus 5, because these are both the same thing. They're both y. So I just did a quick, simple substitution. Now I have a quick equation, maybe not a quick equation, but I have an equation that I can solve, because now I can just solve for x. If you notice, I only have one variable now. I eliminated that y. The y is gone. And now I can solve for x by subtracting 3x from both sides, and I just have 1x. Bring down my 5, I'm done. x equals 5. Because this is 1x, but I don't need to divide by 1. There's no point in writing down 1x, so my solution is x equals 5. So I know x is equal to 5 in this equation, in this system of equations. Now what I get to do with that information is I can take this and plug it in for x. And I can plug it in either x, and it shouldn't matter because the system has the same solution for both equations. So therefore, if I plug x into the first equation, I solve it, I'll get the same y as if I plug it into the second equation. Let me show you what I mean by that. So in the y equals 3x plus 5, we know x is 5, right? So I'll plug in x as 5. So that's y equals 3 times 5 plus 5. Well, 3 times 5 is 15. 15 plus 5 is 20, so I get y equals 20. Okay, perfect. If I had plugged in 5 for x in this equation right here, this would just be 4 times 5. What's 4 times 5? It's 20. So no matter what, I get the same thing, y equals 20. So the solution to this system is x equals 5 and y equals 20. Or we always like to write that as an ordered pair. This is the point at where those two lines cross. They crossed at the point 5, 20. Okay? We're going to keep doing practice problems. Okay, it takes a decent amount of practice, but once you get it, it goes by pretty quick, but we have to know how to solve equations. Okay, let's look at this one now. This should be the first one in your foldable. A little bit more a little bit more to these equations, but the process is the same. So I have two equations in slope-intercept form. Y equals negative 3x plus 4. Y equals 4x minus 10. Okay, so what I'm going to do is, because these are both in slope-intercept form, it makes it really easy. Because this is y. Y is equal to all of this. That means I can take all of this, plug it in for the y here. So really what I have is negative 3x plus 4. I substituted this y equals 4x minus 10. I'm just setting my two slope-intercept forms equal to each other. And then now I just solve my equation. I'm going to add 3x to both sides. That goes away. I still have 4 equals 7x minus 10. And then now I just go through and solve. Add 10 to both sides. Now I got a two-step equation, and I'm trying to get x by itself. 7x equals 14. Divide by 7 on both sides. X equals 2. Here's the part where a lot of people just stop. I can't tell you enough. What I see a lot of people do is they say, oh cool, x equals 2 and I'm all done. Yeah! You still haven't solved for y. So then what you have to do is you have to go through, take this x equals 2 and plug it in into both of your equations. You can plug it into either the top one or you can plug it into the bottom one, and it doesn't matter. And plug it in either one, it doesn't matter which one you choose, and then you have to solve for your y. So just pick the one that you think is going to be the easiest one. So I look at this 4 times x here. I think this is going to be easier because it doesn't have a negative number. We don't like negative numbers. So when I plug in x equals 2 in for x here, that's the one I'm going to choose to solve. So I have 4 times 2 for x. So I'm taking my x equals 2, plugging it in for x, minus 10, and now I can solve 8 minus 10, and that is negative 2. So y is equal to negative 2. So that gives me my solution of x is 2, y is negative 2. Okay, go ahead and try this one out and see how you do. Okay. So hopefully you tried it on your own. I hope you pause, and I hope you gave this a shot so you can check see how you did. So again, I have two things in slope-intercept form, two equations in slope-intercept form. I have y is equal to this, y is equal to this one as well. So that means because they're equal to each other, I get to set both. I get to make a substitution because y is this. I get to plug it in for y in my second equation. So I really have negative 4x plus 2 equals 6x minus 8. So I'm going to start off by adding 4x to both sides. And again, I just like to, I know it's going to keep my values positive. That's why I'm adding 4x. You could have subtracted 6x. It does not matter. Okay. But I have 10x minus 8, so I'll add 8 to both sides. Some of you can already see what the answer is and say, yeah, I got it right, Mr. G. Woo! Divide by 10, and you'll get x equals 1. Now again, the biggest piece here is now you have the x equals 1. You need to take that and plug it into either one of these equations. It does not matter which one you choose. Just pick one. I'm going to choose the second one again because, again, I just have a positive value, so I just like having positive value. So 6 times x, we know x has to be 1, minus 8. That's just 6 minus 8, which is negative 2. So my solution is x is 1, y is negative 2. If you want to be sure, okay, because remember this is x, this is y, so that's my solution. If you want to be sure that this is correct, the way we can check this is I can take this and plug it back in to both of these equations and make sure it works. Okay, so I can take it and plug it into the second equation, and I can take it and plug it into the first equation, and that will just give us a guarantee that we didn't make any mistakes. Okay, now you're going to have some that look like this, which is just a little bit different, but it's the same exact process. So if we notice, I have y equals 3x minus 4. This is in slope-intercept form right here, but the second equation is not in that form. Like, I don't have y equals anything. I have 4 times x plus 3 times y equals 1. So we're still going to make a substitution, but now our choices for substitution are limited. If we notice, I don't have a y equals down here and x equals. I don't know what it is in the second equation. I only know what it is up here. But because this y right here is by itself, okay, so this y is by itself. So what that means is I know what y is. I know that y is 3x minus 4, which means I can take the 3x minus 4 and plug it in for y in my second equation. What the process is that solving the equation is going to look a little bit different. So when I make this substitution, the 4x is unchanged. This plus sign's unchanged, and this 3 is unchanged. But what changes is the y here. But we have to make our substitution in parentheses, because this is 3 times y. Well, y is all of this. So I need to write that as 3 times whatever my y is. Well, y is 3x minus 4. So I took my y and I substituted it in for y here. But when I move that substitution, I have to do it in parentheses because this is multiplication. I have to show that, because what I really need to do, and some of you can already see, is this is going to require the distributive property. Because this is 3 times all of y, well, all of y is 3x minus 4, so I need to do 3 times all of y, all of 3x minus 4. So the 4x stays unchanged. This is going to become 9x, and this is going to become minus 12, because 3 times 3x is 9x, 3 times negative 4 is negative 12, and all that's equal to 1. Okay, now I get to solve the rest of my equation by combining my like terms. I can just combine 4x and 9x because they're on the same side of the equal sign, right? So because they're on the same side, I really can actually do 4 plus 9x real quick. It's 13x minus the minus 12 I haven't done anything with yet, equals 1. And now I have a nice two-step equation that I can solve to get 13x equals 13, and divided by 13, x equals 1. Last step, I found one of my values. I have to take that and plug it into either one of these equations. Again, it doesn't matter. Choose whichever one you think looks the easiest. If I have something in slope-intercept form, I'm probably going to plug it into this one because this is going to take the least amount of work, is this first equation right here. So I know y equals 3 times whatever x is. So that's 3 times 1 minus 4. 3 times 1 is 3, minus 4 is negative 1. So y equals negative 1. So my final solution is 1, negative 1. Because remember, that's my x, and that's my y. X is 1, y is negative 1. So there's my solution. I'm done. That's the point at where these two lines cross. Okay, this is your final problem I have for you. Please, please pause. Try it on your own. See how you do. All right, we'll start off with a joke first. What do you call a number that can't keep still? So what do you call the number that just can't keep still? A Roman numeral. You get it? It's roaming around the classroom or roaming around. Just can't keep still. It's got to keep moving. Roman numerals. Boom. Good one. Okay, here we go. So this one's a little different because we don't have y equals, we have x equals, but that doesn't change anything about what we're doing. That doesn't change anything about this process. I have a variable by itself. I know what x is. X is y minus 4. So I can take whatever my x is and plug it in for x instead of y. That's the only difference, which is fine. So negative 2 times, well, my x is y minus 4. And that's plus 3y equals 6. So again, now I only have one variable, so it should be really easy to solve. I have to start off by doing my distributive property, because it's negative 2 times all of x, when all of x is y minus 4. So that's negative 2y plus 8 plus 3y equals 6. Now I get to combine my like terms. I'm going to combine my y's because they're on the same side of the equal sign. Because they're both on the left side, I'm just simplifying the left side. Negative 2y, positive 3y. Negative 2 and positive 3 makes positive 1. So I just have 1y plus 8 equals 6. Well, a lot of you are saying, Mr. G, why did you write the 1? You don't need to. Yeah, 1 times y is just y. So really, I have y plus 8 equals 6. Subtract 8 from both sides. I feel like we get negative 2 a lot. It's interesting how that worked out. Y equals negative 2. Now, I know what my y is. I still don't know what x is. So I got to take this negative 2 and plug it into either one of these equations. It does not matter which one. Whichever one looks like it's the easiest to solve, I'll plug it into my top one. So my top equation, I'm going to rewrite it, was y equals x minus 4. So I can take my y and plug in negative 2 there. So it's really just negative 2 minus 4, which is negative 6. So x equals negative 6, y equals negative 2. That gives me the ordered pair of negative 6, negative 2. I'm done. And that's all I got. So hopefully this helped. It does take practice. You have to actually do the practice. That's the only way you're going to get successful at this. So please practice, ask questions. Thanks for watching. Gritty is out.